All right, welcome to The Explainer. Today, we're going to trace the incredible journey of AI language models, starting with a revolutionary idea back in 2017 and taking it all the way to the next frontier of artificial reasoning. So let's start with the fundamental question, the big challenge that older AI models just couldn't crack. This one question led to a breakthrough that now powers pretty much all the technology we use every single day.
So here's our game plan. We're going to follow a classic innovation story. First, we'll look at an old problem, then the breakthrough solution that fixed it, and then we'll see how that solution created a new problem and the next generation fix that's tackling it right now. Okay, let's dive in.
All right, so first up, let's really get our heads around the problem that needed solving in the first place.
You know, imagine trying to understand a super complex document, but you have to read it through a tiny little straw, only seeing one single word at a time, and you can only remember the last few words you saw. You'd completely lose the plot, right? That was the challenge for early models. This one word at a time process made it almost impossible to learn the connections between ideas that were far apart.
And then, in 2017, everything changed. A paper dropped with a title that was, pretty bold, "Attention is all you need." And it introduced a totally radical new solution.
So instead of that slow, word-by-word crawl, self-attention gives the model this panoramic view. It can see the entire document all at once. This means it can instantly connect, say, the word "it" all the way back to the robot it was referring to, even if they're paragraphs and paragraphs apart. It's not just reading anymore, it's understanding relationships.
This amazing new mechanism, attention, became the heart of a brand new architecture. And this architecture would, and I'm not exaggerating here, change AI forever. It was called the transformer.
And here it is, the blueprint itself. Now, this diagram might look a little complicated, but this is the original design that really kicked everything off. And at its core, it's really made of two main parts.
So over on the left, you've got the encoder. Its job is to read and just understand the whole input all at once, using that self-attention magic. Then, on the right, you have the decoder. It takes that rich understanding and starts to generate the output, always paying attention to what it's already said to make sure the response is actually coherent.
So what does this all mean in practice? Well, check out this table. The key thing here is the maximum path length. With the old way, the further apart two words were, the more steps it took to connect them. But with self-attention, it's constant. It doesn't matter if two words are next to each other or 100 pages apart, the connection is instantaneous. This is what made these models so much faster to train and way better at getting those tricky long-distance relationships.
So the transformer was an absolute game changer, a hero, you could say. But, well, every hero has a weakness, right? And for the transformer, its weakness is a finite memory. Think of it like the model's short-term memory. It's called a context window. And just like our own memory, if you try to stuff way too much information into it, like an entire book instead of just a paragraph, things start to get fuzzy. Performance really begins to suffer.
And this chart, wow, this is incredibly revealing. Look what happens as you feed the model more and more information that's moving from left to right on the graph. Its accuracy can just plummet. You see that steep nosedive? That right there is what researchers call context rot. It's literally forgetting what it knew.
And the researchers who figured out this next breakthrough, well, they put it pretty bluntly. They said, the quality of even frontier models like GPT-5 degrades quickly as context gets longer. So even our absolute best, most powerful models get overwhelmed.
So what do? How do you solve this massive memory problem? Well, the brilliant answer wasn't to just try and build a bigger brain. It was to give the brain better tools. And this is where things get really clever. Instead of trying to cram a whole book into the model's memory, this new approach basically puts the book on a desk next to the model. The model doesn't have to memorize it. It can just write a little piece of code to say, hey, go look at chapter 2 and analyze that paragraph, and then call itself to go analyze a different part. This is a total fundamental shift in thinking. The old way was all about trying to memorize everything. The new way? It's like giving the model a library card and teaching it how to actually use the library, how to look things up, take notes, and synthesize the findings. And this is what it looks like in practice. The AI is literally writing its own code to solve the problem. It's breaking down a massive, overwhelming task into small, manageable chunks. It decides what to search for, how to process it, and then how to stitch all the answers together. It's just amazing. So as you can probably guess, this new capability unlocks a just staggering leap in performance, especially on tasks that were, frankly, totally impossible before.
I mean, just look at these numbers. The results are night and day. On a really complex task that requires finding and comparing little bits of info in a long document, the base models just completely fail. We're talking scores near zero. But the RLM approach, by being smart and breaking the problem down, the results are incredible. 58 versus 0.04. It's not even in the same league.
So the big takeaway here is that the future of AI isn't just about making bigger models. It's about building smarter systems. We're moving from an AI that just has a big memory to an AI that has great research skills. And that ability to strategize, that is the real breakthrough.
And that leaves us with a pretty provocative thought. If an AI can now write its own programs to break down these huge problems into smaller, solvable pieces, what are the new limits? By giving AI the ability to decompose problems on its own, we might just be witnessing the very beginning of a whole new scale for artificial reasoning itself. What problems will become solvable now?